Hello friends, so today I am going to discuss lead code problem of the day, that is minimum time to complete trips. Okay, so you are given an array. So now let's read the problem. You are given an array of time where time of I denotes the time taken by the ith bus to complete one trip. Okay, so initially you are given an array which contains the elements are of time units. Okay, where time of I denotes the time taken by the ith bus to complete one trip. Now, each bus can take multiple trips successively. That is, there is no like boundary, or there is no limit of how many trips a bus can take. Okay, that is, the next trip can start immediately after completing the current trip. Okay, also each bus operates independently. It means that one bus is not dependent on the other bus. You can think like that the ith bus is not dependent on the jth bus, and vice versa. You are also given an integer total trips. Okay, so total trips denotes one integer which denotes the number of trips all buses should make in total. So total trips equal to 5. It means that the number of trips performed by the bus is 5. So we have to return the minimum time required for all buses to complete at least total trips. Okay, so what finally we have to return is the time taken, minimum time taken by all the bus to complete the total trips time, that is 5. So now let's see the example how the hell 3 is coming in the output. Okay, so the time array is time array is 1 2 3. Okay, 1 2 3, and total trips is equal to 5. Total trips is equal to 5. Okay, so in the first time unit, or one time unit, I am marking the index. So the zeroth index time is 1. So at after one time unit it would have completed one trip. Okay, the 1th index time is 2, so it cannot perform a trip in one unit. And in the second index, the time required to complete one trip is 3, so it can also not perform a trip. Okay, now for the second time unit, the first bus should have completed two units. Okay, because it is only taking one unit to complete one trip. So after second time unit it would complete two trips. Now the time taken for the 1th index is 2. So after two time unit it would have completed one unit until it is 0, and so on. We will now calculate. So it would have completed 3, and in the third unit it would have completed only one trip. And see here, in the third time unit the time taken in the tooth index is 3, so one unit is performed. If you count the total trips is coming 5. So my required answer will be 3. Okay, so that's the reason why 3 is coming here. Okay, so now let's see what will be our approach to perform this problem. Okay, so what we will do now, the brute force approach is we have to start a loop, or we have to run a loop from t equal to 1, t here denotes the time unit, t equal to 1 to, let's say, okay, now another observation that I want you to give. Yes, so what I was telling that there is another observation. If you see that the here total trips is less than equal to 10 to the power 7 and time dot length equal to 10 to the power of 5. So what I'm trying to say, time of I and total trips is less than equal to 7. So total trips it is always less than equal to 10 to the power 7, and the maximum value of time of I will be equal to 10 to the power 7. So what I can guess is that if these two are multiplied will yield a value of 10 to the power of 14. Okay, so my answer or output will be always less than equal to 10 to the power 14. Okay, 10 to the power 14, or the time would be always less than equal to 10 to the power 14. Okay, so now let's see how I can solve this problem. Okay, so our first brute force approach will be, we have to run a for loop with a t variable starting from 1 to infinite, and in each for loop we have to just we will take a variable of sum which is initialized to 0, and then run a for loop belongs to this time array, and sum plus equal to this t divided by x. So this t divided by x will yield the time, or the sorry, it will yield the number of trips. Okay, number of trips performed within time t. Okay, within time t, and if sum is equal to the total number of trips, let's give it a value x or y. If sum equal to y, then return the t. So this will be my brute force approach. Now the problem with this approach will, it will give TLE. So how we can perform this problem in less time complexity? Okay, so let's see. Just give me 1 second. Okay, so let's see how we can perform. So the minimum, we will take two variables. Okay, so I will apply here binary search to solve this problem. Okay, I will take two variables, left and right. The minimum time is equal to 0 or 1, so I will take here 1, and right here is 10 to the power 14. Why 10 to the power 14? I explained here. Okay, I explained here why 10 to the power 14 will be the last time. Okay, up to this time our answer will lie. Okay, so right will be always 10 to the power 14, and we will write here the binary search code while left is less than equal to right. Okay, so I will calculate the mid, which is left plus right minus left by 2. Okay, and I will take one sum variable long sum equal to 0, and for index time array sum plus equal to mid by x, and if sum is less than this variable total trips, which is denoted by y here, So if sum is less than y, then I will increase the left mid plus 1, and else right equal to right will be equal to mid minus 1, and finally return left. Okay, so this is my full code of how to solve this problem. Now let's see how we can perform it here. So I will just here define one macro as define ll as long and sorry, ll left will be equal to 1 and right will be equal to 10 to the power 14, which can be written as 1e14. Okay, now while left is less than equal to right, ll mid equal to left plus right minus left by 2, and I will take here one sum variable, then iterate over the for loop, iterate over the time vector. Okay, and then simultaneously sum plus equal to mid divided by x, and if sum is less than total tips, then sum plus equal to, sorry, left will be increased by mid plus 1, and else right will be equal to mid minus 1, and finally I will return the left as the answer. Okay, so now let's run it. So it is accepted, and now let's submit it. So it is accepted. So thank you friends, and also have a nice day. And also one pretty request I all you I have for you all. Please like this video, like this video, also share and subscribe. Okay.